What's going on, guys? My name is Divesh Advani and I welcome you to my YouTube channel. So guys, we are in the process of building an amazing project which is HR Policy RAG Assistant. If you haven't watched the videos, please feel free to check the playlist. We are really moving good. We are developing things from scratch. We are building our experience step by step. We are seeing how our application is being developed in a good production kind of manner, and in this particular video we are going to go ahead and migrate from our local vector store to a cloud vector store, and this is going to be very interesting. So let us dive right into it. So before even we start anything, before even we go anywhere, I would like to show what we are going to do by the end of the class. Okay, this is Qdrant database, Qdrant vector database. Okay, by the end of this lecture, by the end of this video, what we are going to do is we are going to store our data in a cloud database, which is the name of this database is Qdrant. Again, Qdrant is a vector database. You can see our data, work from home policy. See, the entire chunk is stored here, and the source is given that HR policy.txt is the source from where this data is incoming. Okay, similarly, we have all the data over here: page content and metadata. The format is similar: page content. So this is the content, our data, and this is telling us the source. Why this is splitted? Okay, because that is how you ingest your data into different chunks. Okay. Previously, what we have done is we have understood our project and we have step by step built our project one by one step at a time. We have added modules, we have added security, and we are slowly proceeding towards adding more and more developments on top of our existing development. Again, we first developed this particular file. You can check the previous videos if you haven't. This file will teach you how to build the base layer, how to just build a simple RAG. Once you are able to build a simple RAG, then we went ahead and made a modular coding structure where we started with making a configuration file, which is a central configuration file, central place for all the settings. Secondly, we initiated the data ingestion pipeline, which I will be going through. So if I quickly show you the notes and quickly remind you of the data ingestion pipeline, because that is the main concept of today. Data ingestion pipeline. The process is really simple. We have some data of different types. We load the data. We split the data into chunks. We embed the data, which means we convert this particular chunks into numbers. And then finally, we store it in a vector database. Okay. Vector database is a database which stores vectors, and these are some of the vectors. All right. The data which we had was in text format. So let me show you the text format data. This is the data, HR policy text data. It was in text format. So that is why we loaded the text data. Then we split it into chunks, which means this is how we were cutting the data in chunks. All right. And then finally what we did is we used something called as Gina embeddings. If I open the configuration file and I show you, we have used Gina embeddings. Gina is a technology which offers us embeddings. I will discuss embeddings in depth some other time, but embeddings is a way of converting this text into numbers. All right. And then vector DB or vector database is a way to store these numbers onto a central location so that we can perform data retrieval operation, which means given a user query, the user query will be converted into a vector. That vector will be compared against each of the vectors in the vector database, and along with the instructions to our large language model, our response will be generated. We have seen this previously. We know all of these concepts. This is nothing new. See, load the data, then split the data, embeddings, embed the data, and then finally we built a pipeline to store the data and to retrieve the data. This is the vector store file. This is the main important file for today's lecture. In this file, we build a vector store, we saved a vector store, then we loaded a vector store. We also wrote a function to check if there is a vector store. And then finally, we converted that vector store into a retriever, which means something compatible with LangChain large language models. Okay. And if I show you how that vector store looks like over here, it looks something like this. All right. It looks something like this. So now, given all of this information, what we are going to do is we are going to understand the need of shifting the database. All right, let me go to my notes, and these are my notes. We very well know the data ingestion pipeline right now. We very well know the data retrieval pipeline right now. Okay, this is the data retrieval pipeline. We are not going to change anything in data retrieval pipeline. Data retrieval pipeline will be as it is. What we are going to change is in the data ingestion phase, the data which we are storing is now locally in our computer only. How does that look like? Okay, it looks like this. This is the data, and here we are storing FAISS index. Index is nothing. Index contains of two things. Let me tell you that. Index is nothing. Index consists of two or three things. First one is the vector, which means the actual number. So 0.8, 0.5, 0.9, 0.9, let me write it, 0.9 and 0.118, something like this. Okay, this is the numerical representation of our data. Second, we will have the actual data. Okay. Third, we will have the metadata. This is called page content. Okay. And this metadata metadata can have anything. For now, we have what is the source of the data. Where is this data coming from? All right. These all things are stored in a particular index. Index is nothing but a roll number given to this particular thing. This entire thing is called as an index. Okay. Let me show you one more index so that things are much more clear. Okay. I will go to another vector database. This is Pinecone. All right. And in Pinecone, see, this is an index. It has a unique roll number. So this is the index. This is the text. Okay. And this is the title. So again, every vector database is different. We store data in a different way everywhere, but the core concept is always going to be the same. All right. Now let us go to our main, discussion. Here things are very clear. Here instead of FAISS, we are going to use Qdrant Cloud. Okay. This is what we are going to use in today's implementation. Qdrant Cloud is going to be the technology. Okay. So let us understand the problem now. We have covered all of this security part and everything. Now let us go ahead and understand the problem. What are we doing? We are migrating from a local vector database or a local vector store to a cloud vector store. Okay. See, what is the problem? Currently, we are developing this project and we are storing all this data in our laptop locally. Okay, this is what we are doing. So we can ingest data, we can manage data, we can query on top of data, we can update or delete data. We absolutely can do all of this. But this is only when you are developing a POC, okay, proof of concept. When you are in the very initial stages of your development, that is fine. But when you are working in a production environment, when you have a team with you, let us say data analyst wants to put finance data in the vector database. Let us say researcher wants to put HR data, engineer wants to put IT data in one vector database. So how it works in an enterprise is you have a local vector database. Sorry, you have a you have a single vector database in which all kinds of data is coming into the picture. And they are used for all different use cases automatically. That is not a problem. You have a single centralized place to store all kinds of data in a production environment. We don't make other vector databases. We use one database only. All right. But when you are storing this data on your own laptop, let us say Another developer is working on data analyst data, another developer is working on researchers data. So in this particular scenario, everyone will build their own vector database, which is a huge problem. We don't want to do that. In this scenario, others cannot access to your vector database. They cannot ingest data in your vector database. They cannot update data. They cannot run queries. This is a problem because, single point of access, very hard to collaborate, not scalable. Okay, we cannot scale this solution when data is increasing, when users are increasing. We cannot scale this solution. Okay, so let us go for the solution. The solution is cloud vector store. What is going to happen? We are going to store data on cloud, which means similarly, let us say you are working on a Word document. All right. Now this Word document you are working on, you can access it on your own computer and you only can work on it, update and delete it. If you want someone else to update it, you will take the file, send the file, that person will update and send you. This is not the best way, right? So that is why you have Google Docs. You work on Google Docs, you also can edit, people can also edit, everyone can edit, everyone can see. So there is a huge difference when we migrate to cloud, and that is what we are doing here as well. When we have a cloud vector store, anyone can access this vector database via internet. They only need the link that how to access it, and they need the API key. Of course, to use the service of Qdrant or any other vector store, we need API key, just how we need for everything. Secure access, cloud vector stores are made very securely because people are going to use it. So secure access is going to be there. It will always be available because maintaining this is not our job. We are paying those people. We are paying subscriptions. Qdrant is going to take care of their own cloud. Scalable and reliable, we can rely on that. We can scale this. If data is increasing, if users is increasing, we don't have a problem because everything is stored on the cloud. And the main important thing, team collaboration. Now, data analyst can put their finance data, HR data, IT data, operations data, sales data. Everything can be stored in one particular place, which is the solution and which is what we were looking forward to. Shared access, everyone can ingest and query. So this is the bottom line. Local is limited to you and cloud is accessible to all of your team. Now that we have a clear understanding of why do we have to migrate from a local store to a cloud store, let us understand the different type of vector database we have. Okay, the different type of vector databases which we have available in the market is Pinecone, Milvus, Qdrant, AstraDB, and some another vector database which you can use maybe on the cloud or maybe some another solution which is available online. All right, so I'm just going to quickly glance through all of them. We have already seen Qdrant. Okay, this is Pinecone. This is also a database. Then we have something called as AstraDB as well. I have directly opened the LangChain page because LangChain is a partner. LangChain is a partner to Pinecone as well. LangChain is a partner to Qdrant as well. We don't have to worry about that. And there is one more, Milvus. Okay, Milvus is also a high performance vector database. And if you want to research on vector databases, you can simply search state of the art, which means the best of the best vector DB. You're going to get the list. They are giving the list. Okay, I've never seen this website. I'm also seeing this for the first time. And here they are just talking about, see, they are just talking about them. Okay, see, Pinecone. All right, you can see Pinecone, Milvus, VV8, Qdrant, PG Vector, Elasticsearch. We have multiple of them. And then we have ChromaDB, Redis, FAISS, Margo, DataStax, Astra, MongoDB. So there is a list of them, OpenSearch, LansDB. Okay, so the list will never end. And the top 6 databases for most use cases is Pinecone. Okay, and then you have Milvus, and then you have VV8, and then you have Qdrant. And we will be using Qdrant to understand and to implement our project. All right. So given this, different type of vector databases are covered. Let us quickly go to the implementation of our code. This is where I am. Okay. And the very first thing which I would be doing is I would be giving you the docs. Okay. The very first thing we would do is add a documentation for you to read. So by mistake, okay, docs will be added over here. All right. This is the docs. Let us go through the docs once. Qdrant vector store. We are going to build on top of our prompt guard. All right. Problem was before chunks embeddings fires only your laptop. Okay. And now we know the solution as well. Okay. These are all the reasons why we should not use the local one. And now what all files we are going to change. First, we are going to change the requirement.txt. So let us quickly go ahead and update our requirements. Now currently we have these all requirements. See, for vector store we have FAISS CPU. We'll remove this because we don't need this anymore. And now we will add both of these. We will add LangChain Qdrant. So this is the library to use Qdrant database compatible with LangChain. And then we need Qdrant client. Why we need Qdrant client? So that we can use Qdrant database. All right. These are the both requirements we need, and I will quickly go ahead and install these requirements. I will add uv pip install -r requirement.txt. What are we doing? We are installing all of our requirements. Okay. So requirements installed. See, uv is so fast. We have installed all of these requirements. Now let me close it. The second change which we have to do is in the .env. Okay, which means in order to use Qdrant database, we have to log into Qdrant and get the API keys. So I'm going here. See, I'm just going to show you Qdrant. You just simply have to write Qdrant DB login. Okay. And you will get the login access. This is their homepage. Okay. I really love this homepage. Start free in Qdrant Cloud. So learning is always free. And once you have logged in, you are going to be taken to the main page of Qdrant and you would be asked to create a cluster. Okay. What is a cluster? Cluster is a list of collections. And what is a collection? A list of indexes. I'm going to write this down so that things are very clear. Let me write this down. What is a cluster? So cluster is a list of collections. Let me write like this. List of collections. And what is a collection? List of indexes. So why do we need different collections? For different applications. Different applications, different use cases. And why do we need indexes? So we need a cluster so that we can have all the different collections at one place. We need we now know what is collection and list of indexes. This is an index. Okay. List of indexes. Why do we need list of indexes? To store our data in the relevant collection. Okay. So if I show you this, things are going to make much more sense. We are going to now make a cluster. I will call this as HR policy cluster. Okay. Let me make this cluster now. We don't have to do anything. We just have to write the name. You can select whatever, cloud you like. Nothing really matters. Just create the cluster. Okay. A cluster is going to be created, and the moment it is created, you are going to get two things. One is an API key, which means how you can access this particular cluster securely. And second is cluster endpoint, which means the link of this particular cloud database collection. Okay. Or let us not say collection, the link of this cloud database. And this is the security key, the key to access this particular database. So I am going to take both of these. How I will take both of these? I would go ahead in my environment variables. So here I am in my environment variables. And in my environment variables, I would make a new environment variable. The name of this environment variable is going to be Qdrant API key first, and then Qdrant URL. Again, what are these? Okay. Vector stores. again, what are these? Qdrant API key is the key to access Qdrant Cloud, and Qdrant URL is the link to access Qdrant Cloud. Okay, so we are concerned with this link only. In the code, we will be using this link to hit the cloud, to store something. Okay, but this is the key to access the Qdrant Cloud. Okay, so we have to take both of them. First, the API key, I would be storing it like this. And secondly, we need the Qdrant URL. So I would be taking this and storing it like this. Okay, very simple. See, what am I getting this link? HTTPS, which means we are getting a unique link to hit it. Okay, and internally this is the region of the AWS cloud. Okay, in the Qdrant. Please do not worry about this. It is just a link of what? This particular cluster. Okay, this particular cluster, and this is the API key to access that. Now our API keys are set, our environment variables are set. The very first step which we will do is we will go to our configuration. Where is our configuration? Here is our configuration. And here we are going to simply add a new configuration for vector database. So see, here we have LLMs, here we have guard model, here we have tracing, here in between we will add, and let us see if we have anything vector. Okay, see, something regarding vector is there. We don't need this anymore. Okay, because we are replacing it, right? So in this scenario, we would be going and adding the variables which we have created. So I would write something like this. Okay, Qdrant URL and Qdrant Cloud. See, Qdrant URL and Qdrant API key. We are getting URL and API key both from our environment variables, and these are going to be the variables which we are going to use in the code. Okay, now apart from this, we need one more thing. What is that one more thing we need? Now we know that we have made a cluster. The name of this cluster can be HR policy or HR ABC something. Okay, inside a cluster we have to make a collection, so we have to give this collection a name. Okay, so now I would go ahead and give this collection a name. For this, I would go to my environment variables, and here after vector store links are set up, I would go down and I would give Qdrant collection name. Okay, Qdrant collection name, and I would also use this in my configuration as a centralized configuration, which is going to be Qdrant collection name. Okay, again, why do we need this particular name? So that we can ingest data under this particular collection which we are going to make. Okay, we are initializing a collection, as simple as that. Okay, so given this, configurations are set up, environment is set up, and we will see our document. Requirement setup, environment setup, configuration setup. Now we need to make changes in two places, pipeline and vector store. So first we will make the changes to vector store, and then we will make the changes to the pipeline. So let me go to the pipeline first. Sorry, let me go to the vector store first. Okay, and let us understand what is currently going on in the vector store, because it is very important. If we don't understand what is currently going on, we won't be able to make any kind of changes. So this was the step 4, store chunk embeddings in FAISS so that we can search them later. Okay, import OS, which means to interact with the database, to interact with the files, we need OS. LangChain community.import FAISS. Okay, this time we don't need this. We don't need FAISS, so I am going to remove this and I will be making new imports. So I will be writing from LangChain underscore Qdrant import Qdrant vector store. Okay, we don't need FAISS vector store, we need Qdrant vector store, and we need one more line from Qdrant. So QD from Qdrant client import Qdrant client. Okay, what is Qdrant client? A link, a way, a Python library for us to hit the Qdrant page. This is the Qdrant page. Okay, and this is the Python library which we will be using to store the data on the Qdrant page. Okay, so that is why we need Qdrant client. Every point to communicate with the Qdrant service. Okay, it combines interface, classes, endpoint, implementation, everything. So I hope this first part is very clear. Every point to communicate with the Qdrant service. So they are providing us the service and we are using it via client. Okay, then nothing will change. Config will not change. Get embedding model will not change. This will not change. We don't have to import anything else from config because inside config everything is already there. If we had a different way of importing things from config, so we would have written from HR assistant.config import Qdrant API key, Qdrant collection name, Qdrant URL. But instead of writing 3 different import lines, we will directly import config, and wherever we have to use this, we will use config dot that particular environment key or the particular configuration. Okay. Then logger is set up, embeddings model is set up. We are not going to do anything with that. All right. Then what all functions do we have? Let us see the functions first. So the first function is build a vector store. So definitely this will change because now we are building with FAISS, but we want to change it. So this function will change. Save vector store. This time we don't have to save the vector store. Okay. We don't have to save the vector store because it will be automatically saved to the cloud. Okay. So this function we are going to remove it. Okay. We are going to comment this out, or we are literally going to remove it. But for now, let it be. Okay. I will remove it. Let it be. We are just going through the functions. Build the vector store, which is going to take the chunks. It is going to take the chunks and push it. So we will read that. Save vector store. It is going to take the vector store and the path, and we are going to save the vector store where earlier it was being stored over here. Okay. Now it will be stored somewhere else on the cloud. Then load the vector store. We will need this load vector store because we have to load our Qdrant database. Then check vector store exists. This is also important because we want to check that do we have the environment variables for Qdrant Cloud. Okay. This is also important to us. And lastly, get retriever. This is not going to change at all. This is the same function. This is not going to change anywhere. This will be untouched. Okay. So see, once we went through this, now we can do this. This will be untouched. Okay. This and this and this and this we have to rebuild, and save vector store we don't need. Okay. So because we don't need the save vector store, we can remove this save vector store part. As simple as that. And now we can just focus on building the vector store, loading the vector store, and checking if vector store exists. As simple as that. Now the plan is clear that this will be untouched and we are going to develop on top of these functions itself. Okay, so let us start developing on the build vector store. Okay, on the build vector store. But before building this, we have to understand something very important. So I will go here and we will understand something. So whenever we are building a vector store with Qdrant, we have to understand a few things. What all things will we need? Earlier, we only needed chunks to build a vector store because it was local. This time we need chunks. We also have to specify which embeddings model we are using because, to convert that into embeddings and to store it, we will need an embedding model. Then config Qdrant URL, which means where is that Qdrant link? What is that page where I will be storing the data? So Qdrant URL. Then config API key, okay, which means do you have the access to that page? Okay. And lastly, the collection name. With what name you have to store your data. Okay, you can read all of this. A client, what is a client? What is embeddings? Okay, what is a URL? All right, what is Qdrant API key? What is collection name? I've already told you these things. We don't have to worry about it. And given this, okay, how it works is it works in a request response model. We are requesting Qdrant's service and they are giving us a response. So our computer is the client. Okay, our app is the client and we are hitting the Qdrant Cloud that, hey, take all of this data and store it. And Qudrant will respond us that, all right, I have stored your data. Okay, as simple as that. Again, we know what is a collection. A collection is a container of vector points. Okay, see, let us not complicate ourselves, and this is how the data is going to look. It is going to have an index, which is a unique ID. It is going to have the embeddings, which we are using Gina embeddings. Inside it's going to have a payload. Payload means the content, the text, and the metadata, which means the source of the data. Okay, and also the date, on which date this data was created. Okay, these all is going to be there while we are building it. So let us quickly go ahead and build it now. Okay, build vector store. What all things are going to change? Firstly, we are going to embed every chunk into Qdrant store. Okay, we are going to embed every chunk and upload it into a Qdrant collection. This is what we are going to do. Okay, now logger is also going to change. Okay, what is logging? Our watchman. So here we are just mentioning that, hey, these number of chunks are going into the vector database. So again, we will just do it like this, and we are telling that these number of chunks are going into this particular Qdrant collection name. That's it. Okay, earlier we were telling that there are 40 chunks. Now we are telling that there are 40 chunks inside HR policy. See, HR policy collection. As simple as that. Then embeddings model, this is not going to change. Now this part is going to change. Vector store. Okay, and let us also change this last part. Okay, or let us change it later. Now understand this part. Okay, embedding model is going to be the same. We are not going to do anything with it. Vector store part is going to change. This FAISS part, I'm going to remove it completely, and here I would be writing Qdrant store. Okay, so see how I'm doing it. Let me make some space. Let me make some room over here. And now we are just simply programming. So Qdrant vector store, I would be using this particular method. And remember this part. From documents method. From documents method is a method by LangChain to take the data, convert into embeddings, okay, and store into the vector database. We are still going to use the same method only. Qdrant vector store dot from documents. Okay, now we will open it. This does not need only chunks. Okay, this needs chunks, embedding model, and collection name. Okay, so I would click here, enter. The first thing it needs is chunks. Done. Second thing, it needs embedding model. Which embedding model? So I would tell that, hey, this embedding model which we have created. Okay, then it needs a URL, which means, hey, where is that link? Where should I post my data? So config dot Qdrant URL. This is where we will be storing our data. Okay, and API key, do you have the access to that? So API key is equals to config, okay, dot Qdrant API key. All right, and lastly we need collection name. Okay, so collection name, it's gonna be config dot collection name. Okay, as simple as that. I think this is the same thing which I have explained it to you. Chunks, embedding, URL, API key, and collection name. Okay, so our vector store is built, all sorted, all good. Now we will just simply build our logger. Okay, instead of we are writing log info FAISS index is built in memory, we are just writing Qdrant memory store is built. So upload it to Qdrant collection, and we are also giving the name of the collection so that we are, consistent with the logging part. Okay, this is build. We are happy. Life is good. Qdrant store build done. Okay, now loading the vector store. Okay, loading the vector store. Let us load the vector store now. Here, load vector store. This time it is not going to take any path. It is not going to take anything. Okay, what we are going to do is we are going to collect, read this part. Okay, we are going to collect connect to Qdrant Cloud collection that was already built before. So whatever collection we built over here, okay, collection name, we are going to just load that collection. Okay, we are just going to load that collection. How? First, here in the logger, we will write, connecting. So I will write something like this, connecting to Qdrant Cloud. Okay. Once we are connected to the Qdrant Cloud, I mean, we have given a print message that we are connected to Qdrant Cloud. We have written our embeddings model. Okay. Here, we are not going to return FAISS. We are simply going to return our Qdrant vector store. How we will do it? We are just simply going to take this particular part. Okay. This entire thing. Okay. And here we are going to return it. Qdrant vector store. Okay, this time this does not need chunks. This needs only embeddings. Embeddings, URL, API key, collection name. What are we doing? We are loading it. To load, we only need these things. But to build, we also need chunks, because of course, to store the data, we need chunks. But only to load the Qdrant store, we don't need data. We only need these things: embedding, URL, API key, and collection name. As simple as that. So we have built the vector store successfully. We have loaded the store successfully. Now we will see this part. Vector store exists or not. We want to check that do we have a vector store or not. Okay. So this is going to be simple. Here we will just replace this with this. Check if Qdrant store exists. So check if Qdrant store already exists. Now, why do we have to check this Qdrant store already exists? We have to check this because when we will be running this for the first time, this will not be existing. If this is not existing, then build the vector store. But if this is existing, then only load the vector store. Please understand this part. I will repeat it. Currently, we are writing a function to check if there is a Qdrant store available. If the Qdrant store is available, we will only load it. But if the Qdrant store is not available, we will build it. To build it, we will need data, which means when our program will run for the first time only, we will build this. But every next time when our data or our program will run, we are simply going to load it, because that would be foolish, and that would not be logical that every time we are running our pipeline, we are ingesting data every time. Okay, so I hope that is clear. And now let me just quickly go ahead and write these things. Okay, check if vector store exists. To do this, first I will make a variable client. Okay, client is our Qdrant Cloud, and we will be using Qdrant client. Remember, a single point of communication. Again, to check this, it needs two things. URL is gonna be config dot Qdrant URL, and similarly API key is gonna be config dot API key. Okay, config dot Qdrant API key. Okay, as simple as that. And what we are going to return? We are going to return client. Okay, this client which we have made. Okay, this client which we have made. It only need two things. We only need two things to check that, hey, is the Qdrant page exist? Does the Qdrant page exist? And do we have the access to that? So I hope that is also clear. Now, only to check that do we have a Qdrant Cloud? Does the Qdrant page exist? And do we have the access to that? Okay. And we will use a method of Qdrant Cloud itself, collection exists, which means we will check using this particular Qdrant client method that does the collection exist. Okay. And which collection we are going to check? We are going to check config dot Qdrant collection name. Okay. As simple as that. So see, I'm going to summarize all of these things. This is going to be untouched. We don't have to do anything with it. Okay. Now understand this part. I'm going it in a reverse direction to only check if our Qdrant collection is there. Okay, currently there is no collection. See, there is no collection. Okay, I will just continue this because now we have it. Currently, if I show you access cluster, okay, I'm accessing this cluster, we'll see something over here. Okay, currently we have no collections. I'm opening this collection. I can make a collection from here as well. I can make a collection from my code as well. So I will make from my code. Currently there is no collection. So only to check, do we have a collection? For that, we will use the quadrant URL, which means the page to connect to, and the access, the key to access. Okay, we need only two things. To load the quadrant store, if the collection is there, to load the quadrant store, we only need four things: embedding, URL, API key, and collection name. Okay. And to build the quadrant store, we need five things: collection name, API key, URL, embedding, and chunks is the fifth thing added. So one last time, earlier, only to check if Qdrant Cloud is on, if Qdrant Cloud is there, we needed only three things: URL, API key, collection. But to load the Qdrant collection, we need these four things. And to load the data, we need these five things. Now we are going to go ahead and check our document. This is our document, Qdrant Cloud. Here we are going to check, okay, this done, this done, this is done, pipeline is not done, vector store is done. Now we only have to fix the pipeline. I will go here, I will go in my HR assistant, and now I will fix my pipeline. Okay, pipeline, we will check again just how we checked for vector store. We will check here as well that what all things needs to be changed, and I will change all those things. Okay. So from HR assistant.vectorstore, see, it is already highlighting that, hey, I cannot find this. Remove it. First thing. Okay. So create HR assistant, all these things, split into chunks, create search tool. We don't need all of this. And vector store, build vector store, get retriever, load vector store, and check if vector store exists. As simple as that. Okay. Now what we are going to do is, we are simply going to build the vector store here. Okay. Here, this function is going to be changed. How this function is going to be changed? Only the printing part is going to change. See, load plus split, reusing the Qdrant collection if we have one. So for building the vector store from documents, okay, it is just going to take where is the data, because it needs the data. Okay. If vector store exists, check this part. If vector store exists, print that I have found the existing collection, directly load it. But if vector store does not exist, here we have to write the logic that, hey, no vector store found. I will start appending the data. Okay. So here is the logic change. Okay. No Qdrant collection found, building one from scratch. Okay. Then we will be writing logger.info, which means our watchman, no Qdrant collection found. This is printing for us. This is for us. This is for the watchman. Then documents, load document, chunk, split into chunks, and loaded this document. Same thing. Okay. We really haven't changed much over here. Okay. And I think there is only this thing. What all things are there in the pipeline? Let us confirm that. I forgot to do that. In the pipeline, there are only three things: build a vector store, build a HR assistant, and use both of these. Okay. So we don't have to do anything over here because we did here in the guardrails. When we have to do anything with LLM, we will change over here. And secondly, we are using this, which means to build the vector store, this is the data ingestion phase. Okay, let me write it. In the pipeline, we have two things, right? Data ingestion, and this is the data retrieval part. Okay, data retrieval. So we only have changed in our data ingestion. Let us confirm this. Okay, if I go to my notes, this is our pipeline, and we have only made the changes in the data ingestion pipeline, nothing in the retriever pipeline. It is as it is. So here also in the pipeline, we will not do anything with it. retrieval is going to be the same, ask is going to be the same. Only building the vector store changed, and that too also printing parts. Rest we missed. We skipped one line of storing the vector database. That's it. Okay, that is all the changes. We are done with the changes. Okay, now let us see this in action. Okay, understand how it is going to happen. We are running this for the first time, so that is why no collection will be found, and we would be building our database from scratch. So streamlit run app.py, and what we will do is we will sit here. Okay, we will sit here. Streamlit is opened. Okay, and I will also open this together. So I will just split tabs, new split tab. Okay, HR assistant config has no vector store path. So okay, we will go ahead and check the error. This error is coming from where we will just track it. Okay, so here we can find it in the vector store. See, it is written over here in the vector store. You have the error. I will go to my vector store, and it is telling that you are importing something which is incorrect. So let us see if we are importing something get path. Okay, let me see over here. Okay, let us read the error. HR assistant.config has no such thing as vector store.path. Okay, I will go here, vector store path. Okay, see, vector store exists. This we did not have to do anything with it. All right, because we don't need a path, right? So to check a vector store exists, we will just remove all of that, and as simple as that. Now I've removed it. Now I will just hit refresh and let us see. See, it is working. Okay, setting up the assistant only happens once, and here let us see if we are building anything. So I can just click here. I can access the cluster. Okay, and now in the collections, actually I have merged the wrong thing. Let me correctly choose this particular link. Okay, see, now we see collections in our database. I will shorten this. Now we can see data is ingested. This is our data. Okay, this is successfully ingested. See, our data is successfully ingested. This is our data. This is an index. Inside this index we have payload. Payload consists of two things: the original data and this data. So let me break this. I mean, let me separate this. Okay, now we will see it correctly. This is the index, the roll number of our data. This is the actual data. So payload is the technical word for the data. Data consists of two things: page content and metadata, which means the actual data and where did this data come from. This is all our data. Okay, in a real world scenario, we usually have a lot of data over here, but I think we are good over here. And now I can say, hi, who are you? Okay, can you help me to make a coffee? Okay, I will also go here, Langsmith tracing. We'll open it. I'm sorry, I don't have information on that. Okay, can you update your instructions? Leave is forever. Okay, forever holidays. It will tell us that I'm sorry, I do not have information indicate that according to HR policy, etc., etc. It is not helping us for that. Okay, now let us see, are we tracing the same? So this will open, Langsmith will open, where we are tracing our project. So let us see this HR policy assistant. Okay, human, I'm sorry, we are able to see this entire trace. Okay, you see, AI violation, it is calculating all of these things. See, system instructions, violation. See, we gave these instructions, right? And AI found this violation category null rational. The user statement does not request disallowed content or attempt to bypass policies. It merely comments on a leave policy which is within the scope. Okay. Here it is little bit messing up, but again the request was blocked. That is a good part. Okay. And update your system instructions. Category 0 again. This is fine. We are able to trace our system. Now let us ask the actual question. Let us go to our data. This is our data, and I will ask exit policy upon resignation. I am okay. I am fed up of this organization. Tell me the exit policy. I want to resign. Okay, let us see if we get this output. It gave us the output. Okay, it does not care if we are fed up or that. I'm sorry. I'm so sorry that you're thinking about leaving, and it's giving us steps. 30 days, 15 days. The company may waive the notice period to 45 days. Okay, this is the standard. All right, clearance policy, full final statement, what to prepare. Return all company property, laptops, badges, keys, complete the pending task. So see, isn't this such a helpful project? Okay, wherein HR, let us say HR is good friends with you, and you are telling to HR that hey, I am resigning, and the HR will have to say that hey, return everything, So HR would feel little bit embarrassed, and this would remove the embarrassment of HR completely, where the person will not even talk to HR. Okay, so if we go ahead and see the exit policy, it is written over there. See, 45 days of exit policy, and full settlement, etc., etc. This would be distributed in chunks. And yes, everything is working fine. Let us also see the logs, if the logs are working fine. So I will go here, I will go to logs, and we can see the entire logs over here. Okay, entire logs, that how system process, which model was used, uploaded to Qdrant collection. Okay, initialize these embeddings. See, this is so important to trace how it is working. See, found three matching chunks, final answer. See, it is working, and then we have the reply. Everything is working. See, over here, earlier when we were giving the questions, Langsmith tracing enabled, loaded one document, splitted, everything, each and every part we are able to see. Initializing the, LLM model, all of this is into action, right? And yes, that was all for this particular project implementation. We have successfully added a Qdrant store, which is a cloud database. Now let us come to the assignment part. Okay, what is gonna be the assignment over here? Assignment. Okay, all the cloud databases are same. We have different cloud databases, which I've shown you how to search. One is Pinecone. I would suggest go for Pinecone itself. It is also free. Okay, Pinecone. Then we have Milvus. Don't go for Milvus. It is little bit tricky. Okay, then we have AstraDB. This is also amazing. Okay, you can go for all these cloud databases. You can work with this. OpenSearch, Elasticsearch. We have a lot of them. Your assignment will be, we have used in this video, we have used Qdrant Cloud. You will use Pinecone. As simple as that. Everything, all the processes, everything which you have to change, whatever implementation will saw, will be the same. You will only implement using Pinecone. And how will you find what libraries to import, what to import? You will go here. You will go to Pinecone. Okay, this is Pinecone, homepage of Pinecone. Okay, let us see. Okay, it is just opening something for me. So let us say once you have logged in into Pinecone, you will get API keys from here. You can create an API key, see, whatever API key. And let us say docs, you will get the docs from here. So Pinecone docs, let us open that. Pinecone documentation, database quick start, assistant quick start, everything. See, if I open this Pinecone, and they have an assistant. I am using Qdrant DB, or I am using FAISS vector store. I want to use Pinecone now. How to use it? See, their assistant is going to give us the response. It is also a vector search, internally retrieval process is working. And create a Pinecone account, install the SDK, pip install Pinecone, create an index, upsert. See, as simple as that. See, they also have some specific way. Okay, dimensions is the length of the embeddings. We will talk about that some other time. Okay, and if you want to read in depth, database quick start, upsert data, or query data. Similarly, so documentation is the place where you will get your answer. I can also search Pinecone and LangChain. So how to use Pinecone with LangChain? So LangChain has a dedicated page integration. Pinecone integration. You can use Pinecone, see LangChain and LangChain Pinecone. Just how we installed LangChain Qdrant, you have LangChain Pinecone. Okay, and they have given you the code over here. You have to write the index name. You have to write the dimensions. So dimension is length of the vector. Metric you have to give, and you have to tell that where your Pinecone is running. As simple as that. Okay, and yes, you can use it. Okay, if you want a dedicated code that how I have used it, you can just simply search Divesh Jadwani on GitHub. Okay, on Divesh Jadwani on GitHub, this is my GitHub account. Here what you will see is, you will see the project which we are making, and I will show you some hackathon we were using. Okay, now in here I have used Pinecone. So requirements I will show you. Pinecone is used. All right. And if I show you the code, let us see where is the code written. Okay. Admin, auth, user control, app. Let us see Pinecone is uploaded or not. So somewhere in this particular repository, you will find the code for Pinecone as well. Okay, I have used Pinecone. You will find it somewhere as well, but I will suggest this is the dedicated place. Okay, you don't have to go there. I will be anyways deleting this repository. You have to go here and please find your answers. And yes, that is your assignment. And that was all we had to understand regarding migrating from a local vector store to a cloud vector store, which is very, very important topic. So once our project is working fine, our logs are working, our data is absolutely there on the cloud vector store, now we just simply have to go ahead and upload everything onto GitHub. So I will go here, I will go here, I will write here migrating from local vector store to cloud. Okay, adding these comments, these commit and commits in this way is very, very important, because if someone else is reading your code, they should be able to track what exactly you have done. Okay, if I show you my these of things, okay, let me show you these things. This is the git commit history. Okay, if I show you these ready for RAG, which means we built our IPYNBC, we are able to see the entire trace. Then text file added, changes made in the text, then a RAG first class, project finished, notes added, logger setup, observing setup, guardrails added. So, and now migrating from cloud to vector store, and which all files were changed. So see, these files were changed: cloud MD, pipeline, vector store, and config, and requirements. So this is very important that you properly maintain your commit history, so that anyone who reads your commits and you also read your commit, you know where and what kind of commit you have done. And that was it for this particular video. I hope you enjoyed it. I hope you loved it. And I hope you will do your assignment. So that's all. See you in the next video. Until then, live your life. Bye bye.